Welcome to another episode of Let's Code on IBM Expert TV. My name is Neil Patterson. I'll be your host today, but I am very pleased to have with me Jamie Coleman, who is going to be taking us through the second in a series we're doing on Open Cloud Native Java with Jakarta EE, MicroProfile, and realized on Open Liberty. Today we're going to be looking at this combination and putting applications together on Azure as the cloud platform. And of course, we're using your Kubernetes service to do this work. I'm Jamie. I'm very happy to have you back for this second installment. For anybody that missed the first installment, we did it 2 weeks ago. It is available on Expert TV in the Let's Code archive. So please make your way there and watch it after this episode if you like. Last week or 2 weeks ago was IBM Cloud. And in 2 weeks from now, we will be doing a very similar talk on leveraging AWS as the cloud platform. So with that, I'd like to turn it over to you, Jamie, and we'll get going with your session.
Brilliant. Thank you, Neil. And hello, everybody. My name is Jamie Coleman. I'm a software developer advocate for IBM. And today, like Neil mentioned, we're going to be doing the second part in a series of basically leveraging Jakarta EE, MicroProfile specifications, and using them on Open Liberty with containerized services in different clouds. So last week, I talked about the actual application. We actually built one of the microservices of the application. We took that, we packaged that up using Maven, packaged that into a WAR file, put that into our Docker image, pushed that up to the IBM container registry, and then deployed that to a IBM Kubernetes cluster. Today, we're going to be doing something similar. We're not going to go through building the app, creating the application. We're going to walk through a little bit of the application. I'm going to give you a quick introduction to some of these technologies. And then essentially, we're going to do a similar thing. We're going to deploy it to an Azure container registry. This one will be private rather than public. And then we're going to deploy that to our own Kubernetes cluster. So without further ado, I will get started with the presentation. So Kubernetes on Azure. So most clouds have a container Kubernetes service. Azure is no exception. So Azure actually offers something really cool. So they offer an offering which allows you to basically take IBM Webs for Liberty and Open Liberty, which is the open source version, and deploy that to Azure Kubernetes service. Now, what this does is essentially by starting this offering, this will launch a Kubernetes service for us. It will also launch a container registry, which we can use, and a few other IBM things like the Open Liberty operator, etc. We're not going to be using the operator today. That will be something we're going to look at later on in the series when we start deploying to OpenShift. Okay, a little bit about the technology. I did a similar presentation last week, but this one's a slightly shorter cut down version. So this is a fully open source stack we're going to be deploying to the cloud here. So Jakarta EE and MicroProfile as the Java 8 specifications. Then we've got OpenLib, that's going to be deployed in Open Liberty, and all this is going to be running on the OpenJ9 JVM. Okay, so Jakarta EE, what is Jakarta EE? Well, I've got the Jakarta EE t-shirt on today. So essentially, it's an open source community-driven specification, and it's built for cloud-native enterprise Java. So it's loads of specifications. I tried to include them all, but there was too many to fit on one page, so I changed my mind in the end. But there's loads of different specifications, and they basically extend on Java SE for enterprise features such as things like web services and kind of distributed computing, loads of different things like that. So these are some of the members of Jakarta EE. So there's quite a few of them. And this is kind of the roadmap. So Jakarta EE kind of came around in the 3Q of 2019. It was given to Eclipse by Oracle into the open source community. And since then, there have been improvements and new versions. And Open Liberty supported Jakarta EE not long after. So I think it was like a month or so after, maybe even less from when it was released. And the great thing about Open Liberty is it has a zero migration at its heart. So you can start on any version of Jakarta EE, move your application, move your Jakarta EE, sorry, up to the latest version, and you shouldn't have any issues with your code, which is awesome. So Eclipse MicroProfile, this is essentially an open source community specification, but this is more tailored towards specifically microservices. So essentially, this kind of came around. This came around before Jakarta EE, and a community of different individuals and organizations essentially wanted to create a specification, an open source one for the Java community, so they could build microservices. So that's kind of where MicroProfile came around. These are some of the contributors to MicroProfile, and without them, MicroProfile really wouldn't be where it is today. And the great thing about MicroProfile is it's open source and it's vendor neutral, so you can go to any one of these vendors for support. So this is the MicroProfile 4.1 stack with some standalone projects. So as you can see with MicroProfile, it shares some of its specifications with Jakarta EE. But there's also standalone projects, so stuff to do with reactive, GraphQL, LRA, etc., that work really, really well with the MicroProfile and Jakarta EE specifications. So OpenLiberty, this is the runtime we're going to be using today. This is all open source again. It kind of came around when containers and the focus on developers became more of a thing. So this was really developed with developers at heart. So things like dev mode allow developers to essentially not have to worry about starting and stopping the runtime. They can change their code, they can change their test code, they can even add functionality and make configuration changes to the server without having to keep restarting it, which is awesome. Again, OpenLiberty was designed to have developer productivity at its heart, so it supports the main IDEs, the repositories you can get it from Maven Central or Docker Hub, different build tools supported, so Maven, Gradle, or even Ant if you want to use Ant. And the most popular APIs are supported, so MicroProfile, Java EE and Jakarta EE, and Spring Boot. Testing, microshed testing, JUnit, Aquilian. And it is something you really do need to try out to really get a feel for it. So we'll be looking a little bit about that today. OpenJ9, this is the JVM we're going to be using. This JVM really has kind of cloud native at its heart. So with JVMs, it's very difficult to get a kind of good balance of characteristics because you change one characteristic of a JVM and it could negatively affect a different one. So Cloud Native has its own set of characteristics, things like throughput, startup time, footprint, etc. And OpenJ9 is very, very good at the specific characteristics which are tailored towards the cloud. So this is just OpenJ9 starting up, OpenLiberty booting up with OpenJ9 JVM. And as you can see, the speed that it does that in with just over a second is very impressive. And that's down to improvements that have gone into OpenLiberty and improvements that have gone into OpenJ9 to make it more kind of cloud native. So a little bit about the microservices we're looking at today. So the system service is what we built last week. So again, if you do want to see how we did that, look at last fortnight ago's session. And we basically went in and built the system microservice. And all it really does is it's a REST API. It uses JSON-B and essentially returns the system properties of the local host it's running on. The inventory service we didn't build last week because it's a bit more complex in the essence of time availability. But essentially what this does, it kind of tracks the number of systems you invoke, and it'll store them into a list so we can then have a look at all the systems and all the different system properties. So these are the specifications that are in our microservices. So as you can see, half the specifications are using Jakarta EE, so JAX-RS, context dependency injection, and JSON-P and JSON-B. And then, of course, we're using some MicroProfile specific specifications, so the REST client, config 2.0, and the health check. Okay, so let's get going. Let's get started with our application. So let me make sure I get to the right place. Okay. So let's get started. So first thing we want to do, we need to build our cluster. So when you're on this page, so you basically need to go to your Microsoft Azure portal, and then we're going to click Create New Resource. So if you type in here, Liberty, we can see the different options that are available on Azure. Now, you don't have to use these offerings. You can just stand up a Kubernetes cluster, and you can stand up a container registry yourself. But it's just better just to do this because this sets up all the components we need. So we're going to be just using IBM Web for Liberty and OpenLiberty on Azure. If you want to go one step further, you can actually use the offering which will deploy OpenShift as well. So go click create, nice and simple. Get started. So we need a namespace. So I'm going to create a new one. It basically allows you to easily delete all your resources afterwards. So we're going to call it Expert TV. Okay, so created that. I'm going to do it in my region, which is UK South. And this is just a manage user identity, just basically for billing purposes. Okay, so that's all done. I've got that. Yep. So now we need to create our cluster. I'm going to build the most basic cluster I can probably get away with. So this, I don't need 2 virtual CPUs and 7 gig of RAM for what I'm doing. So I'm going to go for something like this, which is two virtual CPUs and 4 gig of RAM. That's definitely a better size for what we need. Okay, so that's all done. Yep. So this option will create a new container registry, which we want. And do we want to deploy an application? No, we're going to take care of that ourselves. Then Azure will run its validation service just to make sure everything that we're trying to create here makes sense. And once that's all done, we can click create. So this will now go off and deploy our Kubernetes cluster. It will also go off and deploy, well, basically build a private container registry for us to use. Yeah, so we're all good. Right, so while that's doing that, let's go and get started. So we're going to be starting using this repo, which essentially has the microservices we built last time. So I'm just going to go and clone this down. So go and put this in a blank repo somewhere. I've got one here called Azure Demo, so just pop that in there. Okay, so we clone that down, and then we need to go into that repo and into the start directory. And this is basically where we have all the code we need to kind of get started with. So I'm just going to open VS Code, open whatever IDE you want here, just to get started. So the only prereq really you need for this is you need Docker, obviously, because we're building Docker images and containers, and you need the Azure command line. You also need kubectl, but you can install that using the Azure command line, which is quite cool. So let me just make sure our Azure command line is at the right version first. It should tell us our version now and basically set at the bottom say it's up to date, which it is. Awesome. Okay, cool. So now we need to log in. The Azure login is very, very easy. All you pretty much need to do is do that. It should open a browser window, which should authenticate, providing you're logged into your portal. And then, yeah, you should be all logged into the Azure, which is cool. Just let this get started. Okay, it's opened up over here. So you just pick your account. And then it should say you've successfully logged in. Please close this tab. And then we should see on here that it should say we've logged in. Awesome. Okay, so we're logged in. We've got our repo. We're in the right directory. Our cluster is deploying now, which is awesome. So if I go back to home, let's find the resource group I just created, Expert TV. So resource groups on Azure are basically a kind of way to, to group all your kind of resources together. And the reason I put it in a resource group, so after this demo, I can go and delete it afterwards. So that's all good. We'll leave that creating. So what do we need to do now? Now we need to log into the Azure Container Registry. So we need to first check that that's all come up and that's created. So we can click on our container registry here. Yeah, provision state succeeded. So it looks like we have our container registry all set up. Difference to last week was last week we used a public container registry. So anyone can use that and you can pull images from anywhere. Whereas this time we're going to be using essentially a private one, which we've created today. So we need the container registry name here. So we can just copy and paste it from our browser tab. And then this should now log into our container registry, and we should see that with the message login succeeded in a moment. Awesome. Okay, so let's package our application. I will go through the application in a moment for those who missed last week's episode. But first of all, I'm just going to get it all packaging. And when I'm doing the Docker build, that's when I'll quickly take you through the application code, because sometimes it takes a while. Okay. All right, so our applications are built, which package, which means basically all our source code is now in WAR files. What we're going to do is we're going to pull down the latest version of the Open Liberty image, which I presume I've already got, but we'll pull it down anyway, just to make sure. And then we'll go and build our essentially package our war files into our containers. So we need docker build -t system 1.0 snapshot. So that's the first one, and we need to use the Dockerfile, which is in the system directory. That looks all good. Right, so while that's building, so in the system directory, we have a Dockerfile. Again, very basic. You don't technically need all the label things, but we're just pulling from the Open Liberty. We're copying in the configuration, which is in the config file, and then we're copying in the war. And the runconfigure.sh, this is the part of the Docker build which takes sometimes a little bit of time, but essentially it's a script inside the image. So when you're doing a build, it'll run that script to make sure it updates all your packages, etc., that are inside the image, just to avoid any security vulnerabilities. But it only runs when, again, we do the actual Docker build. When we deploy to production, this script doesn't get run. Okay, so while that's running, I'll just take you through. So system, again, just following on from what we did last time. We have our system resource system application, and this essentially kind of puts all our resources into kind of a common place. So it would be system, and then we have the actual resource itself. So this is the API we hit, and that's under the property path. It's a request scope, so it's created on a request, and all it really does is it's a GET request. It produces the media type JSON in a response, and essentially it provides a response with the right OK. So it's a 200 response, which is what we want. So give that a second. It should be nearly finished now. So once that's done, we need to do pretty much the same thing for the inventory image. So we'll take that, essentially the Docker build will put that war into the container. So all we need to do is change this to inventory. And same down here. Okay, cool. So yeah, once that's done, essentially we need to retag these. We need to retag them with the registry server, and then push them up to our registry, which is all good. So we've logged into our registry, which we did in a previous command. So that's all good. So let's go back here. So this is our login server. So it's essentially a combination of the registry name with .azure eco.io. So I'll copy that. Give this a moment to finish running the configure.sh script. So that, yeah, the inventory resource uses a lot of other things. It's a lot bigger application, hence why we haven't created it in one of these. But essentially, let's have a quick look. So this is the API. So here we're essentially doing a GET request to get the properties for a specific host, and then the path param is the host name. We take in that parameter and essentially do a query to get the right host back. Inventory manager pretty much essentially handles some of the storing and adding things. This again is like the other application we did before, so it kind of groups everything under this common path, and then we just have some more stuff around the system client used for doing client builder, etc. And then in the model, we basically handle some of the things for storing our properties. Okay, so let's go back here. Okay, we're all good here. Okay, so like I said, we do need to do Docker tag. We tag, say, system. Oh, let's do Docker images first to make sure they were built. Awesome. Okay, so as you can see, they were built 2 minutes ago, 35 seconds ago, so those are the right ones. So Docker tag, we're going to take, do system first. Snapshot. Ooh, helps if I can type today. And we're going to tag that with, remember, it's this, which is the registry server. And then again, we want to take, that and add that to the end. System 1.0 snapshot. Yep. Okay, so we're going to tag the first one. So yep, now we just need to do the same for inventory. So we just quickly change these. And my hope in the background is our Kubernetes cluster is getting set up and it's ready to go. But we'll find out after we've done this. So right, so last time I checked, our container registry was up and deployed. So I should be able to just do a Docker push. and deploy, push that up. Okay, awesome. While that's doing that, so the first image will take a while because the first time it's going to push all these layers up. And again, it's a private registry, so they will never have existed before. But the second push will be a lot quicker because, again, a lot of this stuff will exist. The only thing that I'll have to push up is essentially the layers with the application code in, and possibly some of the updates that are done by the configure.sh script. Okay, so while that's doing that, let's go back and check that our cluster has come up. Okay, so this is our cluster here. So according to this, it succeeded and it's running. Awesome. Okay. So there is a way we can easily check that. So when this is finished pushing, all we need to do is do a kubectl, get nodes, and if it returns a node and some information about a node, then essentially we know our service is running. Our cluster is running, sorry. So yeah, we'll just give that a moment to finish pushing up. I apologize for my slow internet this evening. So I've been using just general Kubernetes at the moment. You can use operators, and one of the things that are provided with that Open Liberty and Webs for Liberty offering on Azure is the Open Liberty operator. I'm going to start, again, for the first 3 sessions of this series, I'm just going to be using general Kubernetes, because that's what most people use. But with OpenShift, we will be moving on to more advanced things like operators, and then I can show you kind of some of the benefits that operators will bring to you as an engineer. So give this a moment. Some big layers here. So just one more thing. I'll just quickly go back to here, close some of this stuff while we wait. So pretty simple. Again, very similar to what it looked like last week. The only difference is this image pull secret, and I will show you how to create that in a moment. But essentially, because this is not a public container registry, it's a private one. All private registries, by default, I think, all have security enabled. So you essentially need to get the password for that registry, put that into a Kubernetes secret, which then is used by the deployment here. As you can see, we've called it guide secret. And that will allow basically every time Kubernetes goes to fetch an image from our registry, it will use that password stored in that secret to pull that down and authenticate pretty much. Okay, it's nearly done. Just give it a moment. So that's pretty much the only extra configuration I would say we have to do over what we do on the IBM cloud. Of course, you could set up your own container registry on the IBM cloud, but we just use the public default one for last time. Cool, my internet's going very slow this evening. Do apologize, give it a second. Like I said, the next image I push up should be very quick because all these layers should exist. The only layers that shouldn't is the application layer and possibly any discrepancies that were done between the configure.sh scripts. So it looks like these are done now. So next step is to push up our other image, which is our inventory microservice. Good, that went well. Okay. Awesome. And again, the rest are all mounted because they existed already. So again, it's pretty much just pushing up our application code. Okay, so apparently we have our cluster. First thing we need to do is link our local kubectl command line to that cluster. So how do we do this? We do AZ, AKS, so Azure Kubernetes Service, get credentials, and then G. So now we need the group, which we called expert, what was it, TV. And then we need our cluster name. So go back to here. This is our cluster name. We'll take that. So this should hopefully log me in to our, basically make my local command line connected to our one on the cloud. So if I do kubectl get nodes, hopefully our cluster is up and running. Yep, and our command line is pointing to the right place. Awesome. So we've got our cluster already. Now we need to do is go and create that Kubernetes secret to get the credentials for our container registry. So how do we do that? AZ, ACR, Azure Container Registry, credential. Then we do show -n. Then we need the registry name. Let me just quickly grab that. So there's our registry name. Then we need to query that. So -- query. We're going to be querying it for passwords, and we're going to be looking for the first password that is stored, which should be the only password, and the value of that. And then put -o, TSV, enter, and hopefully our password will be displayed. Now, I wouldn't normally show you this if this was an important container registry, but it's something I've literally just stood up for this demo, so I will be shutting it down afterwards. So don't worry about my password being displayed because it will only exist while this demo is running. Okay, so that's all done. So now we need to do is create our secret. So kubectl create secret, and we're going to, it's a Docker registry. Remember, it's called guide secrets. It has to be called that. Well, it doesn't have to be that, but if we change this, remember we have to change what it's called in our Kubernetes.yaml. Otherwise, yeah, it's got nowhere to get it from. Yep, so guide secret. Then we need to provide it with the server. So docker-server equals. Again, the server is this one, the login server here. Okay, then we need Docker username. This is just the name of the registry, so it's just that. Cool. And then we need Docker password. The password is the password we have from the previous command, so just copy that. And then finally, Docker. I don't know actually if this one's required, but basically I just put the email address I use for dockerhub.ibm.com. Okay. All right, so I've created that secret. We'll find out if that secret's right or we've done something wrong there. Docker username, Docker password, Docker server, guide secret. I think it's all good, but we'll know because basically when we try and do our deployment, none of our images will actually deploy, which is not good. Okay, so let's have a look at Kubernetes YAML. So what do we need in here? We need our registry server. So this is basically telling Kubernetes where to go and get our image from that we're trying to deploy. So that is here again. So we just copy that, replace that in our YAML. I do apologize for any banging or fireworks. It's Diwali today, so a lot of people are celebrating outside. Okay, that should be all good. Right, so now we can do our deployment. So kubectl create -f. Make sure you're in the start directory because that's where our Kubernetes YAML lives. Kube.yaml. All right, so we'll go do that. We'll create that. Now, if we do kubectl get pods, hopefully we should see it starting to deploy our pods. So like I mentioned, you do get the OpenLiberty operator with this offering, which you can use. We're not using it today, but just future reference, it's quite good to deploy OpenLiberty using the operator. And the operator extracts away from some of these levels just to make your life a bit easier. Okay, so it should take, I think the first time I started this up, it took about 30-40 seconds for the pods to get ready. Now, for some reason, I don't know why, it takes a lot longer on Azure than it did on the IBM cloud. But if I delete the deployment and restart it again, it comes up in like 2 seconds, which I was a bit intrigued about. I presume the container and the image must be living on the same machine where Kubernetes is, so it's probably deploying a lot quicker. Okay, so everything's all up and running. So we've essentially taken our Jakarta EE MicroProfile application that we built last week, that we deployed on the IBM cloud, and we've done pretty much very similar thing and deployed it to Azure. So let's try and access that. I'm not going to have you all take my word for it that this is running in the Azure cloud. So let's do kubectl. First of all, we need to do is get the service, and we want the system service. So this will get us information about that. As you can see, we have our cluster IP here. So let's take that. Let's open up a new thing. So now we should just be able to put 9080/system /properties, and ta-da! Our application is now running in the Azure cloud on an offering we just set up. And we've done all this while this demo's been active. So there was nothing I pre-prepared for this other than downloading the Azure command line. So that's all good. So now let's access our other service, which is the inventory. Of course, they've got different IP addresses, so let's access this one. I think this one is 9081. We'll just delete that. 9081, and it's inventory/systems. So this shouldn't show anything because we haven't actually invoked the inventory system service and nothing's been stored in there. So let's go and do that. So we want to basically add to our list our other service, the system service. We can find the IP of that here, like we found before. So I'll copy that, add that here, and then this will then go and invoke that and store that into our list. So that should be stored. So if I remove this now, go back here, there is our other microservice that's running on our cluster in the cloud, which is quite neat. So one last thing really before I kind of wrap up, let's just test this. Again, kind of like last week, we just need to provide some certain things for where it's running. So just Maven, we're going to use the fail safe integration test, test plugin, basically. And basically all you need is, we're going to provide it some variables. So the system.ip, which is equal to that one. Yep. And then all we need to add is the inventory IP, which is equal to this one. And if the demo gods are kind, we will run on our tests, and they, rather than running locally against our local deployment, they're all going to be running against our containers all running in the cloud on Azure. First test passed. Yep. Awesome. They've all passed. Wicked. So yeah, that's pretty much it. Remember to go and delete your deployment afterwards. So if you're in the same directory, you can just do kubectl delete -f and then kubernetes.yaml. The process will sit here and hang, because what it's going to do is keep checking to make sure all the different resources that were created via this deployment are being deleted first before the process ends. So basically, when I get control of my terminal again, everything's been deleted and yeah, cleared up. The one last thing I would recommend doing is going into to your Azure accounts, go to your resource group, whichever what it was called, and delete it. Because basically what that will do is delete all the resources underneath it. Now, before I do that, I'm just going to wait for this process to finish, because I don't want to start deleting my cluster and everything while it's in the middle of doing stuff. Technically, that should be fine, but I won't risk it. Okay, well, while that's doing that, again, all you need to do, delete resource group, and it'll clear up all the resources that were created for you, which is quite nice. Okay, so finally, let me just wrap up here. So again, today we've been using a fully open source stack. So MicroProfile, again, all open source, loads of cloud-ready APIs that were built for microservices, and it's got a big community that's growing constantly. OpenLiberty was the runtime we used, which was built for cloud-native architecture. So all microservices, spanning all the way up to, you can use it for monoliths if you want. But it's great for microservices with its fast startup time, it's lightweight, and it's really easy to configure. Jakarta EE is really the backbone of all this. It's open source, like I mentioned, really built for enterprise Java APIs, but for cloud native architecture. There's no vendor lock-in, so you can go to loads of people, and it's got a massive community. Of course, you've got the existing Java EE community on top of all this new community that's come to life because it's now open source. And of course, all built and running on top of the OpenJ9 JVM, which was really built and designed to be a cloud native JVM. There's lots of different links here to get started. I mentioned last week again some of them. I've added in this week the OpenLiberty starter, and that's really great because it basically takes you to a web page which provides everything you need to kind of get started with cloud native applications. And yeah, I just wanted to end by saying thank you, everybody. tune in, not next week, the week after, where I will be doing something very similar with AWS. And then finally, we'll move on to OpenShift and operators for the final session. So I hope you all enjoyed my session today, and happy programming. Thanks.